According to the National Electrical Code 2002, specifically Section 334.15b, wiring methods permitted for branch circuits in multifamily dwellings over 3 stories in height are Type MI cable, Type MC cable, Type AC cable, Type UF cable, and other approved methods. However, there is an exception to this rule. Other wiring methods may be used if they are specifically permitted for the type of occupancies covered in this article. It's important to note that the National Electrical Code does not explicitly exclude the use of Romex, which is Type NM cable, in apartment complexes over 3 stories in height within the 2002 code. However, many local jurisdictions have adopted amendments to the National Electrical Code that require the use of more robust wiring methods such as MC cable in these types of buildings due to concerns about fire safety. Therefore, it is always advisable to check with the local authorities having jurisdiction, often abbreviated as AHJ, to determine if there are any local amendments or ordinances that apply to the wiring requirements for apartment complexes in your specific area. In order to understand the requirements for wiring in multifamily dwellings over 3 stories by the National Electrical Code 2002, specifically Section 334.15b, it is helpful to break down the key elements of this section. Firstly, we need to define multifamily dwellings. These are residential buildings containing multiple separate housing units such as apartment buildings, condominiums, or townhouses. Secondly, the height restriction is crucial. The code specifies that the requirements apply to buildings over 3 stories in height, meaning 4 stories or taller. Thirdly, the focus is on wiring methods for branch circuits. A branch circuit is a circuit that extends from the final overcurrent device, such as a circuit breaker or fuse, to the outlets or fixtures that it supplies. The National Electrical Code 2002 lists several wiring methods that are permitted for branch circuits in these types of multifamily dwellings. These include Type MI cable, which is mineral insulated metal sheath cable, known for its high temperature resistance and durability. Type MC cable, which is metal-clad cable, is a flexible metal conduit containing insulated conductors. Type AC cable, which is armored cable, similar to MC cable but with a different type of armor. And Type UF cable, which is underground feeder cable, suitable for direct burial in the ground. Finally, the code allows for other approved methods, providing flexibility for new or innovative wiring systems that meet the safety standards of the National Electrical Code. The exception to this rule is important to understand. It states that other wiring methods may be used if they are specifically permitted for the type of occupancies covered in the article. This means that if a particular occupancy, such as a hospital or a commercial building, has specific wiring requirements that are outlined in the National Electrical Code, those requirements would take precedence over the general requirements for multifamily dwellings. Furthermore, the commentary highlights that while the National Electrical Code does not explicitly exclude the use of Romex, which is Type NM cable, in these types of buildings, many local jurisdictions have adopted amendments to the National Electrical Code that restrict or prohibit its use. Romex is a non-metallic sheath cable that is commonly used in residential wiring. However, it is not as robust as the metal-clad cables, such as MC cable, and may not provide the same level of fire resistance. Therefore, local authorities may require the use of MC cable or other more robust wiring methods to enhance fire safety in multifamily dwellings. The commentary also emphasizes the importance of checking with the local authorities having jurisdiction, or OJ. The AHJ is the governmental agency or official that is responsible for enforcing the electrical code in a particular area. This could be a city, county, or state agency. It is essential to check with the AHJ to determine if there are any local amendments or ordinances that apply to the wiring requirements for apartment complexes in your specific area. These local requirements may be more stringent than the National Electrical Code, and they may vary from one jurisdiction to another. Therefore, it is crucial to be aware of the local requirements and to comply with them. In addition to checking with the AHJ, it is also advisable to consult with a qualified electrical engineer or contractor who is familiar with the local electrical codes and regulations. These professionals can provide guidance on the appropriate wiring methods for your specific project and ensure that the installation complies with all applicable requirements. It is important to understand the difference between the National Electrical Code and local amendments. The National Electrical Code is a widely adopted standard for electrical installations in the United States. It is developed by the National Fire Protection Association, or NFPA, and is updated every 3 years. The National Electrical Code provides a comprehensive set of rules and guidelines for safe electrical installations. However, the National Electrical Code is not a law. It is a model code that must be adopted by state or local governments in order to become legally enforceable. When a state or local government adopts the National Electrical Code, it may also make amendments to the code to reflect local conditions or priorities. These amendments can vary widely from one jurisdiction to another. Some jurisdictions may adopt the National Electrical Code without any amendments, while others may make significant changes to the code. Therefore, it is essential to be aware of the local amendments that apply in your area. To summarize, when working on electrical installations in multifamily dwellings over 3 stories in height, it is important to follow these steps. Firstly, consult the National Electrical Code 2002, specifically Section 334.15b, to determine the permitted wiring methods for branch circuits. Secondly, check with the local authorities having jurisdiction to determine if there are any local amendments or ordinances that apply to the wiring requirements for your specific area. Thirdly, consult with a qualified electrical engineer or contractor who is familiar with the local electrical codes and regulations. And finally, ensure that the electrical installation complies with all applicable requirements, including the National Electrical Code and any local amendments. By following these steps, you can ensure that the electrical installation is safe, compliant, and meets the needs of the occupants of the building. Let's delve deeper into the specific types of cables mentioned in Section 334.15b of the National Electrical Code 2002. Understanding the characteristics and applications of each cable type is crucial for making informed decisions about wiring methods in multifamily dwellings. Firstly, type MI cable, or mineral insulated metal sheath cable, consists of copper conductors insulated with a mineral insulation, typically magnesium oxide, and enclosed in a seamless copper or stainless steel sheath. MI cable is known for its exceptional resistance to heat, moisture, and fire, making it suitable for high-temperature environments and hazardous locations. It is commonly used in industrial applications, commercial buildings, and critical circuits where reliability is paramount. Secondly, type MC cable, or metal-clad cable, comprises insulated conductors encased in a flexible metallic sheath. MC cable offers mechanical protection to the conductors and is available in various types, including steel and aluminum armor. It is widely used in both exposed and concealed wiring applications, providing a balance of flexibility, durability, and ease of installation. MC cable is a popular choice for branch circuits and feeder circuits in multifamily dwellings. Thirdly, type AC cable, or armored cable, is similar to MC cable but features a different type of armor. AC cable typically consists of insulated conductors wrapped in a paper covering and then enclosed in a flexible metallic sheath. While AC cable provides mechanical protection, it is generally less robust than MC cable and may not be suitable for all applications. AC cable is commonly used in residential wiring and light commercial applications. Fourthly, type UF cable, or underground feeder cable, is designed for direct burial in the ground. UF cable consists of insulated conductors encased in a moisture-resistant thermoplastic jacket. It is commonly used for underground wiring to outbuildings, landscape lighting, and submersible pumps. While UF cable is suitable for wet locations, it is not typically used for interior wiring in multifamily dwellings. In addition to these specific cable types, Section 334.15b also allows for other approved methods. This provides flexibility for the use of innovative wiring systems that meet the safety standards of the National Electrical Code. However, it is important to ensure that any alternative wiring method is properly evaluated and approved by the local authorities having jurisdiction before it is installed. When selecting a wiring method for a multifamily dwelling, It is important to consider several factors, including the building type, occupancy, environmental conditions, and local code requirements. For example, in a high-rise apartment building, fire resistance may be a primary concern, leading to the selection of MI cable or MC cable with a fire-rated jacket. In a coastal environment, corrosion resistance may be a key consideration, prompting the use of stainless steel MC cable or UF cable for underground wiring. Furthermore, the choice of wiring method can also impact the cost and ease of installation. NEC cable is generally easier to install than MI cable, while Romex is typically the least expensive option. However, it is important to prioritize safety and compliance over cost when selecting a wiring method. In summary, Section 334.15b of the National Electrical Code 2002 provides a range of options for wiring methods in multifamily dwellings over 3 stories. By understanding the characteristics and applications of each cable type, and by considering the specific requirements of the project, it is possible to select a wiring method that is safe, reliable, and compliant with all applicable codes and regulations. Additionally, remember that the National Electrical Code serves as a baseline standard, and local jurisdictions often implement amendments that can be more restrictive. Therefore, consulting with the local AHA is critical to ensure full compliance.